Yeah, the stream should be also ongoing. Can somebody confirm? Maybe you, Janet?
Just a second.
It says excellent connection, although I'm not very convinced.
Not yet on my tablet. There is usually a delay, 15 seconds ish.
Yeah,
Fresh.
let me actually maybe try to open it on another device.
Great.
Awesome.
Excited to see some composed stuff.
Yeah, likewise. Trying to figure out whether the stream is.
I think it can just go on like this. I don't think it's a huge problem. Maybe it will catch up. Right now, it disconnected for a second, loads again. I don't know.
Yeah, all right. And is the sound at least there?
It was. Let me check again.
Let me check it too.
Yeah, it doesn't say that it is not
Yeah, the
working.
sound is great. Everything is great. It's just there's a 2 minute delay. I think that's it is what it is.
Okay.
Have you spoken to your internet provider?
Yeah, they're supposed to visit, but they are sort of busy and it's not happening very.
Okay. In that case, I'll just log into YouTube chat, and if you end up disconnected, I'll just let them know.
Yeah, if open desk something, just feel free to unmute yourself and speak up. And I'm gonna be trying to give take a look at a chat on YouTube just for potential questions there too. Right. So the first thing that we are gonna talk about today is about Compose, how everything works behind the scene, and mainly we want to talk about this because there were some questions about optimizations and how we can do some optimizations when it comes to Compose. Now, before I say anything about this, I would like to point out that before you start optimizing, before you start doing anything to optimize the way you are doing the things or the program works, make sure that you actually need these optimizations. Like make sure that the current thing that you're having is laggy, is not okay, is like performance wise it is problematic. And so what I'm trying to say is like avoid premature optimizations because most of the time there is no issues and you may end up having or bringing more issues when you try doing optimizations when they're not where they're not necessary. That being said, we can start with actually the composition. So the biggest thing, like how Compose works internally, is like there is this concept that is called composition. So when we say set content and we call our root composable, basically, we are entering into a composition. So that's where everything starts. And when it comes to the composition, what happens is that it basically scans through the tree and it creates tree-like structure of the composables that are inside. And we are going to talk about those a little bit later. But what is important is that there are three phases when it comes to actually creating this composition. I mean, after the composition is created, how the layouting and compose works, there are three phases. The first one is the composition, where where the system actually compose figures out what UI it has to draw. So what is the description of our UI, and it creates this tree-like structure, so to say. In the second phase, it is the layout, and in there that is a phase where that actually sees where to place these UI elements. So the composition sees what UI it has to draw, the layout sees where it has to place. So there are two steps into the layouting. First is the measurement, and the second is the placement. So it measures the UI elements, and then it places them at the positions where they have to where they have to be. And finally, the last step is drawing. So we have three phases: composition, layout, and drawing. So the composition is what UI will be drawn, where in the layout phase, and then the actual drawings. Now, when it comes to optimization later on, as we are going to be talking about, we may skip some of these phases. In fact, the composition, which is expensive, I mean, the mostly expensive thing. If we can skip the, I mean, I shouldn't have said expensive because I don't want to imply fear. There is a way to sometimes to optimize to skip the composition. So like if there is no necessity to do these recompositions, we can just focus on the layout and the drawing, and we will take a look into practical examples how we can do that. So as I mentioned before, when we say this set content, we are entering into the composition. So the composition can only be created initially, this initial composition when we say set content, and it can only be updated with recomposition. So this recomposing thingy is how we are changing the composition. So the only way to modify a composition is through recomposition. So what I'm trying to say here is that recomposition is essential. Like it is part of the game. So like trying to optimize and not recompose anything is like losing game. Like we don't want to go that way. It is inevitable. We have to have these recompositions. Okay. The next thing that I would like to talk about is the composer. So when this phase or composition is being created, there is this mechanism behind the scene that is called composer that actually keeps track, or that actually I'm gonna explain how I am imagining that in my head. I'm seeing it as a system that keeps track of which state or which value of the state is being read where. So it keeps track of that. Now, when a snapshot changes, snapshot being the state, like when particular thing in the state changes, this composer knows which composable actually was reading that value. And then it can actually only recompose that one. So that's actually a great optimization that Compose has inside. And we are gonna also take a look into, while working this practical example that I have prepared for today, we'll take a look how actually it is basically recomposing only the thing that reads a state that changes. So it all starts from changing the state or the snapshot of the thing that is being actually read. And before we move further, I would like to make a little demonstration here. So when we have a composable function, so a composable function is a specific kind of function. We just put a notation there, but what happens behind the scene, and this is something that you can do with any Kotlin code basically, is if you go in the tools and select Kotlin and then here click show Kotlin bytecode, then it allows us to decompile. So when we decompile, let me make this a little bit more visible. So here is our function. So as we can see here, there is this composer parameter that is being passed in this function. This is what I was talking before when I said there is this composer. So the composer is this concept that actually keeps track of which state is being read where, and so that it can make these optimizations additionally. Okay.
So to summarize it in a shorter way, you're trying to say that in order to update your composable, you have to redraw the UI. How do you redraw the UI? You update the state. And you don't want to redraw the whole UI. So you only redraw the parts that were dependent on the state that changed. In order to figure out which state was dependent to a specific composable, we use a composer. So composer decides, okay, this composable was dependent on this state. This state has been changed, so I have to redraw it so it is updated. And some of them are unnecessary, so we are trying to eliminate those that are not changed, but compose things that they have been changed and redraws them, right?
I think we will get there. But yeah, mostly yes. So the only way to change the UI would be by changing the state that is being read on that place. But it will not necessarily recompose, because we can actually add optimizations. I mean, it depends in what way the UI will change. If it's, let's say, an animation, or some of the drawing, like let's say redrawing the background color, we can apply an optimization that, again, a state change will cause it, but we are not necessarily going to recompose the entire thingy.
So the last session you had some lambdas for animations. I
Yeah.
can say that's what you mean.
Yes. So reinvoking lambda is again something that is recomposing. Give me, guys, 1 minute. Really, somebody's really angry on the door, ringing the bell. I'll be back in 1 minute. Give me 1 moment.
First time seeing some Turkish girl here. Interesting. Okay, he's back.
Sorry about that.
No problem.
Let me. All right, cool. So let's proceed. Sorry about that. Yeah, so we spoke about the composition, about the composer, and then now we are slowly moving towards recomposition, which is like the biggest thing that I would like to potentially cover in this session today. So as I said a little bit before, or at the beginning, I said that the only way to modify a composition is through recomposition. So recomposition is the way to show changes in the UI. That brings us to some concept that is in Compose that is called restartable and skippable functions, or lambdas. So a restartable function is basically the basis of recomposition. It means that we can reinvoke this piece of code, and mostly all composable functions are restartable. So when Compose detects that the function input changes, then Compose can restart or reinvoke this block of code, this sort of function with the new input. So it detects an input and then it can reinvoke. On the other hand, on the flip side, a composable function is skippable if Compose determines that it can completely skip calling that function or that block if the parameter haven't changed since the last call. So going back to our composer, that keeps track of the things, it sees that, okay, this input hasn't changed, so I can basically skip over, or this data that was read here, that was read here, didn't change, so I can skip over. So essentially, it boils down to the values that are being read. And in that sense, we're going to talk a little bit more in details just in a bit about the stability of the data. But basically, keep in mind that it all boils down to a value being read somewhere. And in that sense, if we defer the reads as much as possible, we can sort of narrow which piece is gonna be be recomposed, or when, essentially. Those are also some of the basics of adding additional optimizations with the lambdas that we also will see just in a bit. So like using lambdas, we can also skip recomposition. We can reinvoke we can change some things without recomposing. So when it comes to this reading, because I said the way to change something is changing the state, but actually changing the state that was read somewhere, and by deferring reads, it brings us to a concept that is called recomposition scope. And a recomposition scope would be the scope that will recompose based on a value that is being read. So I think maybe now we can look into a little demo, and then we can maybe explain that a little bit further. So here I have this composable function hello. Now, let's say that here I'm gonna have some state. Let's say it will be variable, and or let's maybe call this text, and this is gonna be I will remember it, mutable state of, let's say, hi. So it's just a string. Let's import this. Now, based on where I'm gonna be reading this, that composable will, if I change, it will reinvoke. So let's say here I'm gonna have a text, where a text is going to be the text like this one. And then let's bring a concept where we will be able to alter this state. So like it can be, let's say, a button, and then this button on click will alter the state. So the text is gonna be hi, I don't know, random next int up to 1,000, for example. Outside here, I'm gonna add a text that will say click me. And because this button will come over this text, actually, let's make this preview. And
so here, if we change the text, we only supposed to recompose the text composable, not the button.
let's actually look into that. So here I'm gonna also add a little padding on top, modifier, padding top, I don't know, 50 dp, so that we can see it a little bit better. Well, 50 was too much, maybe 24, like that. Now let me actually run this. I can run this on an emulator. Let's first select the emulator and then run this. And I mean, there are techniques I'm gonna share a little bit later. I'm gonna share more insights on how we can debug this. For now, we are gonna use the layout inspector. Let me. One second. So is this still compiling? No. So
I think it changed the emulator.
yeah, I don't know
by
why
itself.
it's running. Stop and rerun. Cool. Yeah, let's open the layout inspector now and expand all this. So basically, if I click on the button, as we can see, this text is being read. And because this text basically is in the scope of the whole hello function, we are seeing, like, we can see which part recomposes. The button text inside is stable, like I mean, it is not changing. There is no state that is being read here that changes. So if I keep clicking, you can ignore pretty much this one because this is a button that comes from Compose. I don't know how does it work internally, but like, let's focus on this other thing. So this thing recomposes. Okay. Now let's actually try to put here something like stable text. And here, instead of click me, we can use the text, this one. So this is state that is living in this scope. We are defining it in this scope, and we are altering it inside, like with this click, but it is being read inside this scope, inside the button, right? So let me actually make it like that. It's gonna be easier. So in this scope, it is being read. Now let's see what's happening now. Everything going fine? And on the stream, I see there is the connection is good. Cool. Yeah. So let's expand again. Let's click on this button. As we can see now, the text remains the same. So it is not recomposing. Even though, so what I was trying to achieve here, if I keep clicking, only this text is like inside the button scope is being recomposed. This one here, nothing is being recomposed. So what it means is that, let me hide this. What it means is that it doesn't matter if I keep this state or where I am keeping this state. So I can keep it in a scope that is outside of the scope where it is being read. And Compose can still detect where it is being read. So it can recompose only that thingy. Next, what we could do is, let's bring back this text here. Let's make this one click me. Another concept that I would like to show you is this one. Let's put a column here or row, like column, row, all those. We are gonna look into that just in a bit. Those are containers. Let's run this and see what happens. So I'm gonna click. So here is what happens. The column, so basically everything, like now my text where the state is being read is inside this column scope, right? But how come here the column is not recomposing? It is recomposing actually this hello. The thing is, it is interesting, right?
I think column, row, box, these are skippable.
No,
Not
those
sure.
are inline functions. So these are inline functions. Column, row, box, all those containers are skippable, are basically inline. When it's inline, if we go back to our good friend, which is the bytecode, basically this thingy is non-existent in the bytecode. Like when we decompile, this is inline function. So basically, it's the same as if we are directly working with this scope. So let's open this and see. So show bytecode, decompile. Okay, this is gonna be challenging to find.
Try to search for our string. Maybe we can find it like that.
Yeah. Or like you mean with control find. It's here. So it is like creating some stuff here, but there is no concept of column. Except, yeah, here in some of the metadata, I guess. Yeah. Anyway, so what I was trying to show, I was thinking it's gonna be easier or more visible, but basically this is completely eliminated. Only in the measurements, it is like taking in consideration that the children are going one after another and so on and so forth. So, but what if, for example, I wrap this text into, let's say, another scope, which is not inline. Button, for example, is not inline function. So if I put button, for example, here, so on click is gonna be nothing, and then the button is gonna end here. So I have two buttons. The state is being kept here on top. I am changing by clicking on the button below, on the second one, but I'm reading inside the first button. Let's actually add maybe a little bit of, I can put them into column so that they are gonna appear one after another, right? And then I don't need this padding at all. Let's see what happens now. I'm gonna expand. I'll click on the second. This is interesting, right? Only this one is being recomposed. I mean, of course, the button, when I click on a button, it is recomposing because of animations, like how internally it works. There is animations, blah, blah, blah. So the click causes a recomposition on that component, but actually the state change only recomposes this one inside the button scope. So only this scope is being recomposed. Cool. Hopefully we brought a little bit, or we threw a little bit more light on how internally it is working. By these examples. So what I would say is, like, just pay attention on where a state is being read. And then it is not as relevant where it is kept, but where it is read, it is important, it is relevant. Then an object, let me see what I wanted to show here. Oh yeah, next comes the something that I wanted to mention was this stability. Let me close the preview. There are some annotations that are based on that are helping with stability and immutability in Compose. But let's actually first figure out what are those. So there are two annotations: add stable and add immutable. And as you can see, both of them are coming from the Compose runtime. So when creating state here, basically we are just using a primitive, which is a string, which is stable by default. And when we are mutating it, we are saying the text altogether is going to be a new value. So we are not altering the string, we are reassigning different value. And in that sense, this is immutable. I mean, the actual value that we are changing. So an object that is immutable means that it doesn't change once an instance is created. So if you are thinking about data class, if all properties inside are value, there is no variable, all are value. When we create an instance of this data class, that's it. There is no mutation unless we call copy. Sorry. Unless we call copy, but when you call copy, it provides new instance of the same type. So one instance, it is immutable, it's just that value. So again, it means that it doesn't change once an instance is created. So this means that Compose can detect changes between two instances very easy. So even by calling equals, like there is one instance, another instance, and it can compare, let's say, like imagine that it is calling equals inside, and if it's equals, it means it's the same, so it doesn't have to recompose the composable that is reading this property. So that's what immutable annotation is. So like some of the primitives or data types are by default immutable, but sometimes we can help the compiler understand that, hey, take a look, this one is immutable, so don't worry about it. On the other hand, we have the stable. So an object that is stable is not necessarily immutable. So it can hold inside mutable data. But all the mutable data needs to somehow notify Compose when it changes, so that a recomposition is going to actually happen as necessary. So being stable doesn't mean immutable automatically. You can have a stable one with immutable with mutable things inside, and those mutable ones are not gonna be considered. Yeah, I don't know how to explain this better. I'm just thinking out loud.
I think if it
it's
is
mutable,
mutable,
Compose couldn't really detect changes between the instances. Like if it's mutable, it's the same instance. It doesn't change the instance. And in that sense, it would refer as same instance, but things inside has changed. So think about, for example, a collection. And usually the collections, like list, they are not considered stable in Compose. And then we could use these annotations to, for example, if we are having a data class that has a list inside, we can mark it as immutable, but then we have to take care of actually creating new instance of the list every time we want to alter the list, so that a necessary recomposition is going to happen.
so basically we should promise the Compose that the object won't change, that's immutable. Or if it is going to change, it will notify you. How? It would be a compose state. So it would tell the composable that, okay, I have changed. And then it can recompose.
Yeah,
right?
Basically, we take the responsibility on our side. We say to Compose, okay, don't worry, I know what I'm doing, in a sense.
Mhm. I think if we take a look at some example, it would be great.
Yeah, makes sense. Although I'll have to make more preparation on that. I haven't done preparation for this for today.
I have some example, but I'm not sure if it makes sense. Let me copy paste it in Google Meet chat if you can see it.
Okay.
So here we're passing an immutable, unstable type to context list.
Let me
And even
paste
though,
this here so that others can see what we are talking about.
so you should the first part is copied from inside the composable, wrap it into something.
Like that.
Yes. I import the checkbox.
And a box. Okay. Which one is this? Do you know?
I think the problem is with the if else.
Yeah.
I think.
Okay, circular
Maybe
progress indicator. I think it could be like that. Else text names to string. Okay. Okay.
okay. So when we change the checkbox, our contacts list should not recompose because nothing has changed on it. But it will recompose because the parameters we pass to it, in this case, a list, is not stable. And Compose can't understand that if it has been changed or not. So it would recompose that as well.
Yeah, it will
If you
recompose
can,
for the safety to make sure that there is like potentially new data is gonna be rendered.
So let's try to fix this and avoid the unnecessary recomposition on the list.
Yeah, for that we have to use different type. We can use immutable. I don't have that dependency, but there is this type that is immutable list that comes from Kotlin X collections. Just additional
Mhm.
dependency, and then it's gonna work fine.
Any other way to?
With the regular, I don't think so. But like, here is the thing. First, you have to, as I mentioned at the very beginning of this call. First, we have to make sure there is actually a problem with this. I've been using something like this since I started doing Compose, and I saw in other code bases. So like, essentially, first make sure, because this is string, which is immutable, or if it is a data class that you're having here, which is also immutable, chances are you are not going to have any performance penalties down the road, like significant, for you to do these additional optimizations. Because Compose, especially like the newer versions, they're having the strong skipping mode. They're having some additional optimizations inside. I think it's gonna be just okay. So if you just want to skip recomposition for the sake of it, I'm not sure if that's gonna bring you any benefit. First, make sure that you are actually having an issue with that.
So here, just I have a question. We are reading the state inside the checkbox. Why the whole column scope is getting recomposed? Like that's not relevant to that. The
You are not
checkbox should get.
your checked is, yeah, because column. So you are reading the state inside the checkbox, right? This selected.
Yeah.
And the checkbox lives in a scope that is not, basically it's gonna recompose, because, and especially this column being inline, it's gonna basically recompose the whole thing. But it won't recompose this one because the state is not being read in there.
But it will. You can check, test it in the
But
layout
this one is
inspector.
not being recomposed because of the read of this state. It's because of the list. It wants to make sure that the list content, potential changes in the list content, are gonna be rendered. So the cause of the recomposition of this thingy is not this. But because this scope will be reinvoked and this lives in the same scope, it will just make sure that potential changes are gonna be also covered.
So if we, for example, put checkbox in some other wrapper and pass a state to it and read the state inside that wrapper, will we have the same recomposition, or it would only recompose that wrapper that we put checkbox inside?
Yeah, probably.
I want to know.
Like box,
Yeah.
for example, here, well, not box, but something like, let's say, button, do nothing, and then inside you're gonna have this checkbox. Then it will recompose or reinvoke only this scope.
Mhm.
I think his question is about the contact list, how to the list. He doesn't want the contact list to recompose when the list is not changing. Like, can we wrap the list of in a stable data class, for example, in a data class that we mark it as stable?
Oh, like you mean something like data class,
Yeah.
data, contact list, and then here pass that?
Yeah. Would that solve the recomposition, unnecessary recomposition issue?
Yeah, we'll have to try that out. I don't know from the top of my head. Probably it won't.
Yeah.
But the thing is that actually a problem or not?
I think for this simple example, it's not a problem because it's really very simple. It's two little composables. But if you have like a very nested and long composable, I think then it would make a necessary composition. It will damage the performance maybe.
The thing is it gonna recompose everything inside it, or only the one thing that changed, if something changed? Because like recalling doesn't mean it's gonna go through each and every node. Again, I think there have to be a obvious performance penalty before we start optimizing. A good approach, like in any case, is to use these immutable collections that are coming from Kotlin. So like it's gonna be safer.
Yeah.
Yeah. But yeah, thanks for bringing the thoughts. It's very valuable for everyone, and also for Magdi for the collaboration today.
Sure, man. Somebody in the chat wrote that premature optimization is the root of all evil.
Yeah. Anyway, so when it comes to like what I wanted to talk next is about these recompositions and how we can actually optimize or inspect. There are some toolings. One is the layout inspector that we just saw inside Android Studio. Probably not the best one. It is often slow, but it is there, so we can leverage it. And there are other things that we can do. For example, Composable Metrics It is a compiler plugin, I think, or something related to that we can enable in Gradle, and then it's gonna sort of spit out some flaws that we will find, the Compose compiler. It will just give us suggestions like points or things that we can look into to optimize the things. I'm gonna share a link inside the community. I will make a post with this with the recording, and I'll add links there. But also underneath the stream, the video, I'll also put these links. So the composable metrics, I'm gonna put a link how we can actually turn them on. And there is actually, it is a post from Chris Baines that also explains many of these things that we spoke about today in more details. Potentially can help a lot to understand a bit more, and also how to enable the composable metrics. There is some other tooling like Mendable. It is a command line interface that we can also run some commands to detect and determine things that we can optimize. I'm also gonna put a link to that. I haven't tried it. I have to be honest here, but I just find out, and we can use that one as well, which somebody might give it a try. And additional thing that I would like to share is something that I have shared inside the community. I'm also gonna, in the post inside the community, I'll drop a link, and also underneath the YouTube stream. But I'll just want to show you here. So let me run. It is the application, and I'll show you what is in question when the application is being run. So here I have, how can I minimize this? Yeah. So here I have a list of items, and I have a header. Now the header is in a way, a circle. And as I'm gonna be scrolling down, this circle is going to be, you see, it is like changing first the scale. It is resizing. And then at some point when it's like, I don't know, when the scale is particular value, it starts scrolling together with the list, right? Now, I want to show you here the recompositions. So as we can see here, I can keep scrolling this as much as I want. There is no recompositions happening, right? But there is obviously changes. So, as I said, I made a specific post explaining this before, and I'm gonna link that post in like underneath this video, and also when I will make post in the community, I'll add a link to it. I can quickly show you here how the code looks like. So essentially, I have a screen that is a scaffold that has a top bar, blah, 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 nothing interesting. Then I have a column, and basically this is the canvas. And then here I have lazy column. I need the state to be able to determine the scroll state, like to get the offset of the first item so that I can do animations based on that, or change some properties based on that. Then I'm creating basically back to that optimization thingy that we spoke about. This map returns back to me a list, right, of a user that is not stable or immutable. It is not marked.
But it is, because all the values are immutable,
Yes,
and it is a data
that's what I wanted
class.
to say next. So these properties inside are primitives. So if they are primitives and they are values, by definition, this is stable. So something to be aware of. If this user like belongs to different modules, depends on the modules, I don't know until when it was also considered unstable, but I think with the strong skipping mode now, that one is resolved. I'm not sure about this. I'm just guessing. Anyway, back to the code. I'm creating 50 users here, and then I create lazy column where I'm passing the state, which will determine the offset, so the scroll offset. Then I have an item on top, which is the list header. And as you can see here, I'm passing current scroll there, but I'm not passing that as a value from the state directly. I'm not, like, this is returning me an int, the offset. First visible item, scroll offset. This is an int, but I'm not passing that as an int. I'm passing that as a lambda. Then I'm rendering the items. And then if we take a look at the scroll, at the list header, the list header is not taking int here, but lambda that produces an int. That's the type. And then when I need to use that, I can just call it as a function and then convert it to float, do something on top of that. And by using graphics layer, we spoke about this in, I don't know if it was last stream or it was internal in the community. But basically leveraging these lambda modifiers, we can optimize recompositions or skip recompositions. And we can draw things. The graphics layer specifically can help us with things like rotation, scale, translation, those kind of things, alpha. And I leverage that here to draw the header. Anyway, I will add a link to the detailed post that goes over this, how this works and what are the optimizations. So I think it's gonna be easier. And yeah, so that should cover what I wanted to talk about, the first topic of the agenda for today, which was composition, recomposition, and optimizations. Or optimizations, I should have pronounced it better. Cool. Next on the agenda, although we are pretty much on time, we have 5 minutes. So to sum up, I'm gonna make inside this inside the post that I'll make, and underneath the stream of the video, I'll make links. I'll add links for Composable Metrics, for Mendable, the command line tooling that will help us with performances. And also I'm gonna add a link to the post that describes this thing that I tried to show here, where recompositions are also optimized. Hopefully it's gonna help somebody. Now, another topic, we didn't have many topics actually for today. Another one was AI integrations for Android development. Sardar, actually, a member inside the community, asked about this, and he gave a try to some of these, but he was asking what is the experience of other developers when it comes to using AI for Android development. Truth to be told, I haven't tried AI for development, like any integration when it comes to like inside Android Studio or something like that. But his question most probably was about trying it inside Android Studio, whether you are using some sort of integration of Cursor AI or any other LLM that you might be using, whether you have that integrated in Android Studio, or what integration do you have, how do you use it, or yeah, anything like that. Copilot, Gemini, Nitesh just mentioned, those are actually integrations for Android Studio for sure. They are working. But is there any integration or maybe plugin for Cursor AI, for example? Does anybody have any insights, or maybe what is your approach, guys? What do you do? Do you throw some code at ChatGPT and then copy paste it? How do you usually do that?
Sometimes having it integrated in IDE helps for doing some repetitive tasks, but if you want to do something serious, like none of those really work. They are so stupid. They are not intelligent at all. That's my experience.
I wanted to actually point out on that because that was also part of the question. In my opinion, AI cannot really replace human just yet. Maybe never, like as a developer. So the idea is that we can leverage this AI tooling to actually make our job easier, but we definitely need to know what we are doing. We definitely need to know what it spits out and what is usable, and in what way we will change it. So in a sense, as a Stack Overflow, but like faster. And then you still have to, like, if you find an answer on Stack Overflow, you still have to edit it, you still have to change it, find out how to like make it work, fix. In that sense, AI can help, but again, we have to actually be the sort of the ones that are gonna pay attention on the things that are happening, how they're happening, whether that works or not, whether that's what we want, and maybe end up spending more time explaining to AI what do you want to do compared to actually doing it yourself. So maybe for some, as Magdi said, repetitive tasks, or because when it comes to like programming, the moment when you need to start coding something, more or less the programming is done. So like maybe you can save some time to actually code, or ask this thingy to do the coding for you. The way I am seeing it right now, but maybe like yeah, let's see how the future is going to turn out. At least that's my impression so far. But I have to admit I haven't used that extensively as well. Cannot go ahead.
Yeah, I agree with that. I use ChatGPT quite a lot, but only because it knows the syntax, which I don't. But conceptually, it almost always makes some stupid mistakes, and I just need to keep correcting it and reiterating everything it does, and weed out unnecessary logic it implements. And so there is a lot of problems with that. So currently, the only help I find in AI is that I don't need to look up how certain things are written in Kotlin. I can just ask it to, okay, write me this and this and that, and then I need to correct it what it wrote for me.
Yeah. Santiago has a great comment actually on YouTube. He says that Copilot is so amazing because it has your code, like class or whatever you have as context. With that, it will give you nice answers. So this is actually this is something I definitely saw, and that's what you basically need. You need to take the context and then ask it to do to produce something like based on that context, so that it saves you typing the code. So in that sense, it can help you like become more productive. That's how I see it. So this tooling, we should leverage it in our disposal, like to become a little bit more productive or do something sooner.
Yes, I used
Another,
to,
Beshoy, go
yeah,
ahead.
go ahead.
okay. I used also Cursor. Cursor is very, very interesting tool because it takes the whole project. He understand what are you what you have done, and when you ask him to do something, it give it in the same context of what you have done. This was يعني very impressive for me. But actually, the most benefit for me for the especially Judge said ChatGPT is the argument. يعني when I use مثلا something and he is providing something else, I argue with him why you are using this, how is this affecting the performance, how is this affecting the memory, and this way of communication it make a lot of stuff more clear.
Okay, so that's very interesting. Good insights. So in a sense, you can learn something like that is not maybe 100% clear. Is that what you're saying?
Yes, exactly. And it's not about copy a snap of a code and paste it in my projects. Mainly, it will not work perfectly, but this point of challenging, yeah, for me, it's the most benefit of a challenging. Why you are doing this this way? What is the best way of doing this? What is the alternatives of doing this? يعني this type of questions with AI makes a lot of stuff more clear.
Awesome. Yeah, thank you. Thanks for sharing your insights. Okay, so Yeah, I was just checking if there is any questions in the chat. Probably there isn't anything. So yeah, that's it from my side, guys. If there are any questions, happily would answer or try to answer. Other than that, we can close the call for today, and looking forward to the next week.
Great job. Thanks for asking our opinions and doing some preparation based on that. It feels really good. Thanks, man.
Of course, yeah, and thanks everybody for contributing with the topics, because that always helps to prepare something in front, and then we have more substantial communication, more substantial co-working session. And actually, I'm trying to make it more collaborative. So like when more people are contributing to this, it makes more sort of valuable, I guess. Because like not somebody can know everything. If that makes sense. Nitesh, go ahead with your question.
Hi Joe.
Hello.
Good evening.
Good evening.
Uh, I have one query about navigation graph. In my project, I have a login screen. So in login screen, I have a login button, and another I have one sign up button. So when I will click on login button, then I will go in home page, or when I will click on sign up button, then I will go in sign up page. So I'm facing that issue. I'm clicking on login button, but uh, I'm not going on home page. So that is my issue.
Okay, so
And
um,
second, yeah, yep,
the idea is like if you can keep the questions relevant to the topics of today would be great. So to help you still with this question, the repository that we have shared inside the community, the open source repository for Android devs, I'm gonna also put a link in that to that. It actually has this exact example. It has a welcome page with two buttons, and then click on one goes to one, click on other goes to other. And actually, that's this very same repository that is here. So if I just
yeah,
let me quickly clean up what I've done here and run it, and then you can see actually. So this is the screen. Sign up, login. So sign up goes to one page, login goes to another page. So actually, you can
yeah.
just go inspect the code and you will find the answer.
Okay.
I'll drop a link in
In
the
welcome screen, yeah.
yeah. So I'll drop a
All right.
link
Yeah,
to this.
yeah. All right.
Cool.
Yeah.
And then if you have
Thank
additional
you.
questions that are not relevant for today's session, we can also discuss them. Like you can send me a DM. I always answer.
Yeah, hi Joe.
Hey, Eduardo.
Yeah, the lazy row you used for the demonstration, is it available on the GitHub repository?
Which one?
The one that has scroll with the
Oh yeah.
animation is
The code is available inside the community. And when I make the post for
okay.
this session today, I'm also gonna include the code so that you guys can take the code and run it on your own. And basically, you can just literally all the imports and everything is there. So like if you just paste it on a new file, it's gonna work.
All right.
Yeah,
All right.
I'll make sure to include it. No worries.
Mm.
All right then. That's it. Thank you everybody for the participation, for staying in the call, for contributions. Looking forward for the next session. Yeah, Chana just
Joe.
shared the link to the repository in the call in the chat, so you can use it, Nitesh. So
Yeah,
yeah,
yep, yep. I got.
um,
Yeah.
that would be it. Thank you everybody. On Monday, I'm gonna make new posts with new topics, so please contribute to the topics so we can have something to
Joe,
talk about.
Joe, Joe, I had a one last question. Uh, I am also curious about work manager.
Yeah, as I said, please keep the questions relevant if you don't mind. So like if it's
Yeah.
nothing related to this, let's discuss this offline. You can send me a message in the chat in school.
Or sorry, or you can also keep it in mind, and for the next Wednesday you can just post as a question.
Exactly. You can also contribute on Monday on the post. You can put this as a question so we can discuss it in a live session next time.
Fine.
Cool.
I have a question, but I will ask in next class.
Yeah.
I will ask in next Wednesday. Yeah.
Every Monday I make a post inside the community collecting topics. So you can drop it as a topic there and we can discuss it on the co-working session.
Yeah, fine. Yeah.
That being said,
Thank you.
Thanks everybody once again, and looking forward to seeing you next week.
Thank you.
Thank you,
For
Joe.
the people on YouTube, if you don't mind, please click like, subscribe, maybe even share. So it's gonna help the whole community around us improving all these things and learning better.
Yes, sure.
Cool. Cheers, guys.
Thanks,
See you.
everyone. Bye.
Bye.